então vamos do this now. actually some of it more.
Okay.
You have still like space on the side to it. Okay, welcome back, everybody. Let's get started. This is our very last technical lecture for the year. And again, Kieran is going to take over that, and he'll be teaching first about V3 brushes. This is something that we'll be needing, not even in the next homework, but in homework 5 or 6, homework 6, I think. Then he'll be teaching you some advanced JavaScript concepts that you might need in your projects, like promises, asyncs, and so on, things that you would need if you do data loading. You've seen those, but you didn't have to write any of those yet. So yeah, Kieran, please take it away.
Okay. So as Alex mentioned, we'll do this lecture. Like today's lecture will roughly have 2 major parts. Like the first one is specific to D3. We will do D3 brushes, some D3 functions like groups, which would be really helpful if you need to wrangle your data really for your projects or even like the further homeworks. And then we will do like a brief example of creating your own linked visualization. So for this homework, you're already doing kind of a linked visualization where you select some things in the map that changes your line chart. But we'll see a slightly complex example of where you, let's say, brush a scatter plot or brush one visualization and that updates the other one dynamically. And then for the second part of the lecture, we will do some advanced JavaScript concepts. And in that, we will go through some of the good to know syntax for JavaScript, which includes like destructuring of lists and objects. And we'll cover what that is, how that makes your code slightly easier to write. Then we will go through, after destructuring, we'll go through promises, which are kind of one of the biggest things in terms of how to load your data and how to handle asynchronous JavaScript, which might include events if you want to do events that way. And then the last thing we'll cover is basically some helpful debugging tips, how to debug your code, what debug tools we have apart from console.log. And we will not cover any specific debuggers, but what we will cover is different console methods which are helpful for debugging. Okay, so we'll start with we'll start with the brushes first. So brushes essentially are a way to interact with a visualization where you can use the mouse pointer or any pointing mechanism to select an area of the chart. So let's look at an example here. Here we have this area chart, like a big area chart, and like a slightly smaller area chart, and we can see that the smaller area chart is actually the range. It ranges from, let's say, July to April approximately, and we can brush part of this to kind of get a zoomed in view in the top area chart. And we can see as we move our brush, the top area chart updates fluently. This allows us to create really cool visualizations where we can show details on demand. Or also, this is also like one of the ways to implement something like a semantic zoom, where we can have a much smaller view which includes a larger part of the data, and then allow people to interact to see details of a smaller part. So let's just start with how we do brushes in D3. So so the function which allows us to create brushes is the D3 brush function, and there are variants of it. The regular brush function creates a 2-dimensional brush, uh, but there are other functions like brush X and brush Y, which allows us to create 1-dimensional brush either along the X-axis or the Y-axis. And the way we do brushing is we simply start by creating an empty group element, as we see here, and then give it a class of brush. This is more or less the setup we need. Like this is more or less the things we have to do in the DOM to kind of show the brush. Just add a group element, give it a class brush, and that's pretty much all we have to do. We don't have to do any enter, exit, append, or any other things to render our brushes. Then the actual logic for the brushing and the drawing of the rectangles, the drawing of the selected area, that is taken care of by our brush functions. So here we have 3 variants: the brush, brush X, and brush Y. Just calling this function initializes a brush, which really doesn't do anything. Next thing we want to specify for the brush function is the extent of the brush. And extent is basically the top left and bottom right of the area that the brush is supposed to cover. And we need to specify this so that when we are interacting with the brush, we know what the limits of the brush are, and we limits of the brush are, and that helps us get the mouse position or the brush position in that limited area. And we'll see how to do those things. But essentially, initializing a brush, first step, add an empty group element to actually house the brush. Second, create the brush, initialize the brush function. And third, give it an extent. And the final step is to actually just take the group we created, the empty group, and do a dot call and pass it the brush function we generated. This syntax is basically the same as axis syntax. We create a scale, add an empty group for the axis, and then do axis dot call and give it the scale. That renders our axis, and this basically sets up our brush. So just a quick example, doing those three things will, doing these four steps will essentially set up this. We can just doing these steps will let us draw brushes like this. And now we'll walk through the code quickly. So we start by selecting our SVG, setting the height. We give it, so we add our base group. We add, so we, in this example, we'll add all three different type of brushes. So the X brush, the Y brush, and the two-dimensional brush. And for that, we append the three different groups here, the X brush group, Y brush group, and the two-dimensional brush group. Once we have those positioned, now we actually start adding our brushes. So here we are drawing these rectangles for in each group just to kind of show this area. This is not required for the actual brush. This is just so that we can clearly see the areas. And then as a last step, we initialize the brush function. So for the X brush, we say brush X, the extents go from 0, 0 to width 50. So width basically is the width of this brush, the width of the brush we want, like the width of the X brush we want, and we give it a static height of 50, because the X brush, the height is always static. It's not really the area, it's more like this top and bottom corner. And then as a last step, we do X brush group dot call X brush, and which basically initializes this. If I comment this out, and you see like clicking here doesn't do anything while this still works. So essentially this dot call is what's doing the actual magic of adding all the events, rendering the brush, handling the events which allow us to move and resize the brush. So D3 really makes it quite simple to add a complex interaction like this with by essentially like 4 lines of code. But as you see, like this brush is actually not doing anything. We haven't really specified what to do with this brush. So let's take a look at how we actually, now that we have this brush working, it's rendering, it has events which allows to drag it around, move it around, resize it, etc. Interact with the brush in a more meaningful way, like connect the brush and our data layer. So brush actually exposes three different events for us where we can hook into this brushing mechanism and do something when the brush is drawn or moved or removed. And the three events are essentially the start of the brush, the actual brushing, which is the movement of the brush, and the end of the brush. And again, so this like it's pretty like from the names, it's pretty standard. Like it's basically when we click our mouse, that's when the brush start is triggered. And after that, as our mouse moves while we have pressed the button down, the actual brush event is triggered. And when we release the mouse button, that's when our brush end is triggered. And again, this D3 has implemented this in a way where it also responds to touch events rather than just mouse click. So we don't really have to worry about, usually if you do a mouse click event, you also have to kind of handle the pointer event. D3 actually does that for us. The actual start event actually works for mouse down and touch start. So that's kind of a nice thing if you're designing for like tactical interfaces. So now quickly, let's take a look at what the final output we are aiming for. We essentially have this scatter plot. This is the iris dataset, and we want to write code where we draw a brush and the selected points under the brush are highlighted in a different color. Pretty straightforward. So let's look at how the code is. So we start by our standard, like selecting the SVG, giving it the height. We decide on X and Y column from the data. We actually get our data set, map it properly, make sure the X and Y values are floats. We get the min and max for our X and Y. We create our scales here. This is like, I'm skipping through this lot of the stuff because you have done it enough times in your homework to be familiar with what it does. And then, yeah, again, we append our axis, draw our axis. And at this point, we are drawing our circles. So till this point, we have completed rendering of a regular scatter plot, which we have done like enough times now. And so the new thing that we start is we start by appending a group element to the base plot, giving it a class brush, and then we just store it in the brush group variable. And now we initialize our brush. We set the extents from -10, -10. So we start slightly. So if we draw the brush, we can see we go slightly outside the range of our area, just so that so this is like slightly a nice thing to do, because it basically we don't have to struggle with like selecting points on the edge, where if we just allow the mouse to go slightly ahead. So we so it's essentially like adding a negative margin. Then we do the same for the bottom right, where the bottom right point is width, height, and then again a +10 extra margin. And then we add our 3 events. So for the start event, we really, when we start brushing initially, we really don't want to do anything. So all we are saying here is, on start of the brushing, just console log the selected points, which would probably be nothing. Like there would be no selections when you just start. And we can actually take a look at this. If I just do this, we see there is a brushing started here. And if we expand it, we can see the extents of the brush, or the area of the brush, is essentially 0, because this is the top left area of the actual brush, and this is the bottom right corner of the brush. I hope it's visible. Yeah. And we can see this area, like it's 0, right? It's the same exact point. So brush start really does nothing, but you can use brush start to essentially do something. Let's say when you have an existing brush and you want to do something other than just removing the brush, when you are and if you have a brush and you click again, if you want to do something other than the default behavior, which is removing the brush, you can utilize the brush start event to kind of realize that, hey, a new brush is being added. Then we specify what happens on the brush end, and brush end is basically when we know that the final brush has been drawn and the mouse has been released. Again, so brush end takes like brush start, brush end, all the brush events take in a function where we get the event, and the the property of interest in the event is the event.selection property, which is essentially the extent of the brush at that given point. So brush end, kind of using event.selection from the brush end, is the most ideal point, because that's when the mouse has been released and the brush won't change anymore till the mouse is clicked again. So we store this selection in a new variable. We created an empty list of selected indices, and we checked if our selection variable is defined. For example, if we do this, we can see when our brush is completed, the selection is actually null, because essentially we didn't draw the brush. We just clicked on a point and let it go. And we can see our start and end were the same points. That means when the brush was completed, there was no brush on the screen. We just clicked on one point. So that's the reason we actually check for a selection. If there is a selection at the end of brushing, then we kind of store the selections in this left, top, right, and bottom variables. And this syntax looks slightly weird. This is something we'll cover in the advanced JavaScript part, like in a bit when we complete this. But essentially, what we are doing is we are taking this nested array of selections, this is basically an array of arrays, and storing it in 4 variables called left, top, bottom, and right. And then we are iterating through the entire data set, and for each point in the data set, we basically take this brush extents, which are pixel values, use scale.invert to convert them into our data values, and compare the point whether a point lies within the extents of the brush. And if it is, then we just put it in the selected indices array and repeat for all the points in the dataset. Once we have that, at we select all the points in the scatter plot, we remove the highlight class from them, and then we loop through our selected points. We loop through our points and check the points that were selected and add the highlight class back in again. Doing this basically allows us to do this. Like if we have this brush selected, now if we draw a new brush, it removes the old highlights and adds the new ones back in. So that was our brush end. Then we have this then we have the last event, which is the actual brush event. And brush event is, if we look at the console log here, so the console log for brush event is brushing. And if we just look at our console here, brushing is the event which is triggered basically the most times. Brush start and brush end are triggered only once per brush when we actually start and end. But brushing essentially is triggered whenever the mouse moves. And brushing is how, and this event is where we basically do the dynamic highlighting of moved points or real-time response to the brushing. We can write code where we draw the brush and nothing happens till we let go, but that's not ideal, right? We want as the brush moves, the points to be updated. So the code for that, when your mouse is down, mouse is clicked and moving, goes in on brush event. So again, the logic here is essentially, well, not essentially, it's exactly the same as the brush end logic, because all we want to do is get a selection. If the selection exists, we want to loop through the data set, find the points which are in the brush extent, create a list of selected indices, and then basically loop over the selected indices to add the highlight class to them. That's it. Like that's all we are doing in this. So we can see that usually brush and brush end have the same logic, but you can do other things on brush end. So let's say you want to do something like when we are temporarily brushing, you want to highlight points as red, but when we actually let go, you want to turn them into other color. You can do that using different logic for brush end and different logic for brush. So yeah, and then as a last step, we just take our brush group, do a dot call, and pass it the brush function we defined here. So yeah, so that basically gives us this brushing logic. Again, if here we use t3.brush, if we use brush x or brush y, it will create a horizontal or rectangular brush. Everything else remains the same. The selections remain the same, the extents remain the same. Before I had just have like a brief comment to make on the brushes, but before that, we'll do some questions on brushing. Okay. Yep.
So can you move the actual design? It looks like it's highlighted here.
No, it's the same.
So once you create it, is that still a regular brushing event?
Yes. So it's just, so for example, now that the brush is created, if I click on it to resize, it still triggers the brush start event. But the difference is the brush start event has the current selection of the brush. And for example, if there was nothing on the screen, the brush start event kind of has the same exact point, like zero selection. So essentially, it doesn't matter if you are doing a new brush or changing an old brush. You kind of have to remember brush start, brush, and brush end. These are the three events you have to like basically remember.
And can you drag it?
Yep. Yep. Okay. Cool. So before we move on to groups, brief comment about, so the logic we use here for checking brushes is essentially writing a for loop over our entire data set and checking if each point is within the brush range. If your data set is really big, it might get really expensive doing that when you are moving the brush, because it essentially does it every time it console logs. It's actually checking for the all the points are if they are in the data set, and this might get crazy if you have, let's say, like 10,000 points on the screen. So D3 actually comes with like some helper libraries, and so this is the GitHub page for the D3 brush library. Like the links are there in this tutorials page. This is their example website. This was the focus. This focus plus context was what we saw here, this example. You can go through all the different type of complex brushing. So for example, here in this example, they add like handles to the brush, so you can have something fancy looking. There you can also combine brushing with transitions here. So let's see. Yeah, so when you kind of move the brushes, you see the colors and like the edges change slightly, and also when you let go, it moves transitions back to its original place. You can look at the code here, so you can essentially combine brushing with all the things you have already learned. But the point I want to show is this, the quad tree brush. Quad tree basically is a data structure which kind of takes your data and divides it into a tree-like shape to facilitate a faster searching. D3 already has this built in, and you can basically pass your data to this quad tree function and use the quad tree to search whether what points in your brush are covered by the tree. or what points in your or what points actually fall within the brush range. And this is quite fast. Doing this is quite fast because essentially we write two for loops, one for checking if a point is in the brush range and the second for highlighting them. So doing it with this many points, it's still responsive and fast enough because we are using like this quad tree function. I won't go through the logic for how the quad tree works or how to set it up. It's really straightforward. It's very similar to the way we set up generators in our layout lecture. We just initialize, pass it the data, give it a range. That's pretty much it. But if you use brushing interactions in your project and you have really big data and you run into trouble with like lags, remember there is a helper library in D3. This is part of D3. So there is an helper function to facilitate faster searching. Okay. Now we move on to the next part, which is D3 groups. So again, so this like today's lecture is will have like slightly discrete topics. Like to groups is not related to brush at all. It's basically group is part of the D3 array module, and it gives us helper functions to basically do a group by. If you are familiar with like any of the data science libraries, you can do a group by on a particular categorical attribute. D3 groups allows us to do that in the JavaScript environment without writing weird loops. So we load the iris dataset, do a dot then. We will see what this dot then syntax is in the next part. But essentially, remember, like at this point, the data is loaded, and then we just use the d3.group function, give it a data, and then give it an accessor function to tell it what property to group by. So actually, before we log the group data, let's just log the actual data. Yep. So if we log the actual data, we can see that it has petal length, petal width, species, and we are telling D3 to group this data by the species attribute. And if we log this data, yeah, we end up with this object with this data structure, which is the D3 specific data structure called an intern map. And this is like a bit similar to the JavaScript's inbuilt map, but it's like a D3 structure. It had some helpful. It internally actually just uses the JavaScript map, as you can see here, but it adds some D3 specific things which we really don't want to worry about. So if you open this, we can see it's basically a list, or it's basically an object where the key is the group name or one of the group IDs, and the array is the elements belonging to that group. So yeah, using this, we can just essentially do a group by. Um, there is another function which is basically the same as group, but if we run this code again, we can see that instead of getting an yeah, instead of getting an array, we get this intern map object, and intern map object cannot really be used directly with the bind syntax because it's basically a key and a value pair. It's kind of weird to access. So D3 actually helps us by giving us another function which unfortunately they just call it groups instead of like group. And all it does is it takes the object and converts it into an array of arrays, where the first element of each subarray is the key, and the other element is the actual array. And yeah, this is just another way to do it. We could do exactly this by actually just using a JavaScript inbuilt functionality. So here we have, let's clear the console. Let's take a look at this. We have this group map object. We have this intern group object. We can actually convert this to an array of arrays just using the inbuilt JavaScript syntax of object.entries. And we essentially, oops. Okay, the object.entries doesn't work because it's an intern map, not a JavaScript map. But object.entries essentially gives us a data structure which looks similar to this data structure, which is just an array of arrays. And you can just use D3 groups to kind of get an array which you can bind directly to D3 without doing anything in between. Then here is another example where what we are doing is now we have our data which has the name, the amount, and the date. So essentially, and we can see for we have two entries for the person Stacy, and we'll do a group by on name and then a group by on date. So actually, let me just comment out this console log, and we can see we have this data structure where we have a key, and the value, instead of being an array, it's another map object where the sub key is Jim. So basically we did a group by twice. We first grouped the dataset by the name, and then for each entry in each group, we actually grouped it by the date again. Again, this is quite a complex data. This is quite nested. So if we can use d3.groups to, okay, let's comment this and let's uncomment our d3.group results, and we essentially have a nice looking array of arrays where we can keep looping through this and binding it to our elements to create something more complex. There is, so this is not part of the slides, but I'll put a link to it. So in the new D3 array update, there is actually something called as flat groups, which kinds of flattens this nested arrays and nested objects. Let's try doing this. So instead of nested groups, we can just do flat groups here. Let's see if I remember the syntax. Yeah. So when we do a flat group, instead of this, here we see we have Jim and an array, which again has a nested array. We get Jim, the date, and then the final array of object. So it kind of flattens out this nested data structure, saving you some trouble. And this is quite like, this flat group syntax is slightly new, like it just came out in like the D3 array version 3, which is kind of newish. But yeah, like you can also consider using this if you really want to reduce your work. But you could also do the same thing by using the result of the group and writing a for loop over it. So yeah, that covered our groups. Any questions about grouping? Okay. Yeah. So now we'll take a look at linked views. So linked views is related to our original, the first part we covered, which was brushing. The final output we want essentially is this: two scatter plots where when we brush one, it highlights the corresponding points in the other, and the other scatter plot has no interactions. So let's see how we would create something like this from scratch. So we would, like, for this, for the first part of our code, we would assume that the code for building these two scatter plots is there. We would just see how these two plots will be connected. So we start by selecting our SVG, creating two subgroups for our plots, plot 1 and plot 2. We append the rectangle, and then what we do is first, if we run this code, we can see our data first. Yep. So we can see our data here. So it is basically the Irish data set which we logged earlier. And then we create an instance. So we have a scatter plot class where we call it the controlled scatter plot, or the controlled scatter plot, and we create an instance of our scatter plot plot. And controlled scatter plot means this is the plot on the right which has no interactions, but it is still being highlighted using the other one. And the setup for it is pretty simple. We give it the height, the width, place to plot 2, which is like the rect element, which is the group element inside which it should appear, the data, and then the actual X and Y columns. And we'll see the code for the scatter plot class at a later, like after once we see how they both control. And then we create a helper function called update other plots. This function basically calls the update function on controlled scatter plot. But right now this function really doesn't do anything. It's just created, right? It doesn't really do anything. What we then do is we take this update function and pass it to our scatter plot with brush class, so that the scatter plot with brush class knows what to do when brushing is done. So scatterplot with brush takes in all the same values as the regular scatterplot, except it takes a last parameter called an update function, where we pass in the update function, which in turn calls the update for other scatterplots. So this is like the most basic way of how you would set up a linked visualization. So something, and this, you must have seen an example of this in your latest code, right? The both the line charts and the maps have like an update function, and we kind of have to figure out how to call the update function of one from the other on based on what interaction. So this code will generate this plot. So now let's take a quick look at the actual classes. So this is the complex one, right? The scatter plot with brush, because it draws a regular scatter plot and then actually updates it. So this class has two functions, and this is just an example of how you can structure your code. You really don't have to do this way. The more important point is the logic, right? There is a draw function. So there is a draw phase where we actually draw the scatter plot. And I'll skip through this because this is mostly just drawing the scatter plot. The only extra thing in this, what we are doing is we are setting up the brush where we do a dot brush, specify the extents, and then we specify handler for the brush and the end event. And this is a shortcut to specify two events at once. We can just space them out. So this basically is the same as writing on brush and on end separately and giving it the same function. You see, we don't really do anything on start because we don't have want to do anything fancy on start. So again, here we start with our selection. We select the points. The logic is exactly the same. And then what we do is at the end of our brushing, we call the update function on itself, on the scatter plot itself. And we can see if we go to the update function on the scatter plot, the update function takes in the selected point. It actually does the highlighting part. It highlights everything. It highlights the selected points correctly. And the other extra thing it does is it updates the other view. And we can see this other view is essentially, and this other view is something that we passed, is the function we passed in. It calls this function. So when we passed in this update other plots function here, that is being called in the update function of the current scatter plot. And the other scatter plot is basically just a regular scatter plot. It has a draw function where you draw everything. It has no interaction. There is no addition of brush, and the update point just loops through the selected points which it got and highlights them. So yeah, like this is like the basic example of how you would set up link between two views. You could, like as an exercise, just quickly like at home, try just adding some code here to make sure you can draw a brush in the right plot and also update the left one. So yeah, and yeah, please go on. Sorry. Yes, exactly. Yeah, like you can pass in. Yeah, we are just passing in a method. You could like pass in the entire instance and then call the dot update, but it's essentially up to you. Yeah. Okay. So this last part is basically like I'll talk about like using D3 with other front end libraries. This is more for your projects, but before we do that, any questions on this D3 part? Because after this last part, we'll move to JavaScript. Okay. So, okay. So now in this course, we are using a lot of D3. If you are already a web developer, you must have noticed that D3 has quite a bit of weird syntax. That's not how you usually write web code. So D3 kind of tries to emulate this update cycle, which we kind of naturally get from libraries like React, Angular, where you kind of declare your code, you kind of write just HTML with some JavaScript thrown in, and it automatically figures out how to update. So, and those libraries are great, right? So I personally like using D3 with React to kind of create like everything for my research, essentially. And there are a couple of different ways to do it. And at this, you can replace React with any library of your choice, like Vue, Svelte, or anything you want, right? If you're not familiar with any libraries, then D3 is actually a great library to actually update your DOM. But like these other libraries do make our life simpler by kind of having this component structure where you can declare reusable components and call them. They have like state management and stuff to kind of interact between like your server and stuff. Then D3 can provide all of these things, but you have to write a lot of boilerplate. So before we talk about like how to integrate D3 with React, also a helpful hit is like there are already, like I have two examples of kind of like the visualization libraries already written in React. So if you're like using React somewhere and you want to add a viz, you don't have to like actually write any code. If your viz is quite simple, you could just use one of these like React libraries. So this is the Victory package. it has a lot of this animated interactive visualizations. So let's see, do they have an interactive version here? Yeah, so this one has like tooltips and hovers and everything. And then there is a package called React Viz, and I forget, I think this package was actually made by Uber at some point. I don't remember exactly, but it has a lot of, if you go to, let's say, examples, yeah, it has a lot of this charts, like really already styled for you. You can, like, they also take like themes you can give it, so you can customize it for your brand or whatever. But they have a lot of different plots already kind of there for you. But again, so a lot of this are quite opinionated, right? It's really hard to customize them. You have to kind of stick to what they have, and it depending on how it's written, it might be really hard to add custom interactions to it. So if you want to do some complex interactions, essentially you will have to write your own. And that's the last point I want to talk about with respect to D3 is you can combine D3 with any of these front end libraries, so to say. And there are three ways to do it, right? The first one is, let's say, and I'll talk as if I'm using React, but this you can substitute React for any library you want. You can say, we can ask React to render everything except when it comes to rendering our chart. We can ask React to just call the D3 code. This is like the simplest way to set it up. Problem with this is React or any of the front end libraries try to control our DOM, and D3 also controls our DOM, and that might lead to weird issues with rendering where both try to re-render things and it might get slow. The other is to kind of allow React and D3 to be black boxes to each other, where you kind of have a function with all the D3 code and React calls the function and forgets about it. React never touches the DOM generated by D3. This is slightly hard to get it right, because if you get it wrong, it might fall back to the first option where they both try to change the same thing and you really have a problem. And the last thing is something which I really like and it's just super efficient is I don't use D3 for actually rendering anything. I use all the D3 functions to calculate stuff like the layout generators, the line generators. But once I get it, I just use React to render it and pass it the D3 calculations or the D3 values. This is super efficient if you use your front end library correctly. This can be super efficient. Problem is there is almost zero documentation on using D3 in this way. All documentation for D3 rely on using D3 to render something. So you kind of have to figure out how to render your tree with React, because D3 will only give you the position of the nodes. So that's kind of like the last point with on combining D3 with something else. Yes, please.
You were with chocolate stuff, you use React this to render it.
No, I use like plain React. If you're using React Viz, you don't even have to worry about calculation, right? React Viz just takes in the data, gives you a Viz. But the problem is it only gives you the visualizations they have. If you want something customized, like it's no game. And it depending on, so I haven't really used React Viz recently. I don't know how good they are now, but they really struggle. They used to struggle with like if you had multiple charts from React Viz, it was really hard to kind of connect them interactively. Yep. Okay, any questions related to D3 in general? Because after this, like I'll move on to the JavaScript part. Okay, cool. Let's talk about JavaScript. Let me see if I've covered everything in this. Yeah, okay. So I've covered all these links. Okay, so now we will do the JavaScript part, and this particular part of the lecture is quite discrete, right? We'll cover a lot of different things which are might not be connected to each other, but try and like go through these things and you will find some of this really helpful when you're doing your projects, because during your projects you will like really start from scratch, right? You won't have a scaffolding like the homeworks. So some of these things might help you set up how your data loading works, how to like write slightly better code for like your loops, how to debug. So first we'll start with the destructuring syntax. So destructuring is something that was, well, when I updated this lecture, it was new, but now it's already like 4 years old, I think. So destructuring basically, let's take a look at how destructuring works. So here is, we have an array with 1, 2, 3, And the way we take out, if you want to store each of these elements of the array, in 3 variables, this is the standard way to do it, array 0, 1, and 2. And if we log it, this is what we get. This is quite straightforward, right? So in JavaScript, we have a new syntax where we can just do array 1, 2, 3. And when we declare our variables, instead of using 3 lines, if we declare them in one single line using square brackets, JavaScript kind of figures out that 1 goes in first, 2 in second, and 3 in third. And it essentially gives us the same answer. Yeah. And I think this, let me try this. This is redundant, right? This, we don't really need this. We will still get the same. Yeah. So essentially what JavaScript does is it takes in the array and sees that you have declared 3 variables as arrays. It kind of maps them one to one. Now let's see what happens. Sorry. Mm-hmm. You can do that, but like again, like the point of the destructuring syntax was to make it easy, right? A one liner to get 3 variables out of one array, and let's have a one liner code, because like it's quite this is like a quite common use case to do it, right?
This is very common if you're trying to value.
Yes, we have that. Okay, so yeah, so and actually like so as Alex mentioned, like this is useful when we want to return something, but actually there is a much simpler use case for this. Let's say you want to you have an array, you just want to create a copy of it. If you remember, like JavaScript does, like if you have an array of objects, JavaScript kind of stores them by reference. So let's say you create an array, assign the store it in a variable a, then assign a to b and change b. It also updates a for some reason. So this syntax quite kind of makes it easy for us to kind of just copy the array. So for example, here we have our original array 1, 2, 3. We put it in copy 1, and here to create the copy 2, instead of just assigning copy 2 equals copy 1 or copy 2 equals original array, we kind of use this 3 dots, which is the spread operator. So the first operator we saw was the destructuring operator, which basically square bracket with multiple elements. The second is the spread operator, which allows us to spread our array inside a new array. So it takes each element of the array and puts it in a new array and basically creates a copy. And so we have copy 1 and copy 2 here. If we change the original array 1 to cat and console.log it, we can see that our original array 1 was changed to cat. Our copy 1 also changes to cat because it was just done using regular assignment and JavaScript does it by reference. But copy 2 actually didn't change because we used the spread operator. That means it created the copy of the array. Yes. No, it won't make the copy of the internal object. It would make the copy of the array, but you can nest your spread operators. Like I'll cover this. So you can also spread objects. If you spread your object, then it will create a copy of that object. So spreading or using this 3 dots as a syntax is essentially equivalent to copying the top level. If you have an object inside an object, it copies the top level. The internal, it just creates a reference, and this is basically just the way JavaScript does everything, right? It tries to store everything by reference as much as it can. So yeah, so let's take a look at this. So okay, we have this big list. We console.log it. This is like another helpful syntax where, let's say you get an array and you're kind of just interested in first 3 elements. You don't care about the others. You can destructure them in this way. You can say var1, var2, var3, and then for the remaining you could say dot 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 remaining vars. And when we console log this, we can see it stores our first 3 elements 1, 2, 3 as individual elements, and everything else goes inside a new array which goes from 4 to 10. So this is kind of like JavaScript's way of saying that you specified 3 variables and then you did a spread operator. So I'll put remaining elements in this one new variable, which will now become an array. And this is quite good if you want to. You can keep this as like an unused variable, and these three are the ones you actually want to work with. So this allows you to get like a smaller subset. But again, this syntax is great if you know you want certain number of objects before, because you have to actually write the variable names. This is not really a dynamic way to do it. uh yeah, like even here, so another way to do is to go the other way. Let's say we want to skip the first three values and just get the other values. Let me just comment these out for now. Yep. So if we want to just skip over the first three values and get like a smaller list, we could do this, and it essentially skips the first three assignments because there is no variable to assign them, but it still assigns the rest of it to a shorter list. And again, like all of this is done using the same spread operator or the triple dot syntax. Now, this is what we used for selections. If we quickly go back here, let's, yeah. Yeah. So when I did this, we can see that brush actually returns, like the brush event has a selection property, which is an array of arrays. So it's an array. Inside it, there are two elements which themselves are an array of two elements. And we can use this nesting, we can use the nesting pattern here to kind of get data out of it without using indexes. So here, like this example is actually much smaller. What we do here is we know that selection is an array of arrays. So we declare our variables using a similar syntax. We declare an array, then we declare two subarrays where the variable names go left, top, right, and bottom. And it kind of assigns them in the order of left, top, right, and bottom. So these four, the actual selections kind of get assigned left, top, right, and bottom. And we can do this arbitrarily long, right? So here we have this really weird syntax of an array with first element being a variable a, the second element being an array with two variables, and third element being an array of arrays again. And we can make this as complex as we want, as long as the value we give it mimics the structure. These variables are kind of assigned like one to one. So a goes to 1, b goes to 2, c goes to 3, because our declaration of the variable and the value follow the same exact structure. If there is a slight change in structure, we either get an error or they get assigned to one of the variables as an array. So that's, so using this syntax is great when you have something predictable. Like we know event dot selection is always an array of arrays, and it that array of each sub array has always has just two elements. It's great to use then. If you have loaded your data and you don't know how many elements it has, this is really bad syntax to use. It will throw errors at some point if you don't know the length of your incoming data. Uh, Another fun way to use this is to swap your values. So we have x comma, we declare it, let x comma y equals 23 32, and then here we say create a new array saying x y equals yx, and this essentially just swaps the two digit. X is 23 and x is 32. A quick way to swap without creating the temporary variable or anything. Yeah, so another use of this spread operator is in functions. So let's say you have a function where you have a function but you don't know how many arguments this function can take. You want to declare a function where you can give it whatever element, like 3 arguments, 4 arguments, depending on your data. You can declare the function using triple dot numbers. So what that will say, what that will tell JavaScript is the arguments which this function will receive should be combined in an array. A simple way to do is this is just give the function an array in the first place. But if you don't want to do that, if you want to specify each element using the comma syntax, you can just declare the argument name using the spread operator, and JavaScript kind of combines them into a number. So if we actually do a console log here, we can see that this basically the 1 2 3 we passed in were converted to an array of 1 2 3. Again, this syntax has like, I have used this like in really like rare cases. I would rather just pass in an array in the first place instead of doing this. Yeah, but the point is like it's there if you want to really use it. We can also destructure objects. The way we destructure arrays, we can destructure objects. So here we have the object which represents the band Led Zeppelin, the period they were active from, and all the members. We console log dot it, and we see we print our object, right? Now, what if we want to get out the name, active name, the active period, and the numbers as actual variables? We can just do this by declaring the variables name, active, and members, and to this variables we assign the object lz. Now the only criteria is the key of the object here should match the variable name, and JavaScript will assign it properly. If we, let's say, have another, like if we create another object here, let's say test, and to try to do console log test, it says undefined because it couldn't find a key called undefined in the original object lz. And this is actually great when you load in a data set where you may not know the length of the data set, but you know that each point in the data set has same structure, and you want to get out, let's say, IDs for all of it. You can like write a for loops, let's say let's ID, or or if you have to do a one key, you of course you would do dot ID. But let's say you want three keys, so instead of like writing 3 lines of code, you could take out the keys using this syntax, and that really makes your life easier. um you can also do this like as we saw with the nesting of the arrays. You can do this arbitrarily. So let's say we define the same object, now we define another object which has the name Led Zeppelin. Basically it's the details about about a particular album. We have the release date of the album and length, the total length in minutes and seconds. So we choose to represent this is something similar to like data you would get from a Spotify about a particular band or an album. So this is another, so this is like another version of the, this is like another date, another album, another data point. And now what we want to do is to our original object which represents the band, we want to add a new property called albums and assign it the array of their actual albums, which is lz albums and presents. And if we log this, we essentially get this object, and we have added a new property to this. So you can add properties to your object. So if you load a data from, let's say you load a data from your file for your project, now to each data point you want to add a new property based on some calculations, you can just do it. Now that we have this really complex object here, this is something really bad. You shouldn't really do this, but you could name your variable, create variables for this entire, like create variables in the shape of your data, and it will actually create this. So it will create albums, as it will create band name, the lz album name, release, etc., as new variables and assign them the data because the shape is the same. And this is like really convoluted example just to show how it's possible. I would really recommend not doing it. Yes. Yep. Mhm. Yes. Yes. We created a new property inside lz which is called albums. Yeah. Yeah. And if we expand it, like you can see Led Zeppelin, like the album and the presence both present here. Sorry. You mean like both albums have different fields? Yeah, it doesn't matter. So let's say for the Led Zeppelin album, I add something like test 1, 2, 3. If we expand this, we can see the new albums will be added. Like Led Zeppelin will have test 1, 2, 3, and presence doesn't have it. It doesn't matter. It will just create array of these. Like it will take the two albums and put them in an array. It doesn't care if they have the same shape. It's kind of like when you write the code, you have to kind of check. Okay. So yeah. So as I was saying, like this is a convoluted example of like destructuring everything out of an object. Like really don't do this. Like it's really confusing to read. But I'll just quickly walk through the syntax. What we are doing here is we are telling JavaScript from the lz object, take out the name property and store it in a variable called band name. So we are saying take out the name and store it in the variable called band name. Then we are telling JavaScript to go inside the albums key which we added, and we are saying that albums key is an array with two objects in it, and then for each object, for each album, take its name and store it in lz album name variable, and for the other, store it in a pr album name variable. And we can see, like, if we console log using these variables name, lz album name, pr album name, they correctly log. So this, like, they are being created. uh Now the final thing, we saw, like, if we add a new key here, like if we add a new key to our destructuring which is not present in the object, it is like declared as undefined. So here, yeah, let's do it here again. Test and console dot log test. You can see the test is undefined here, right? Now you can, so you might want to use this syntax to, like, get something out from the data you read for your project. You might end up having one bad data point which doesn't have a value, so you will get that as undefined, obviously. So in that case, JavaScript allows us to do the same syntax. So we know that lz variable doesn't have a variable called union dates. Now if we try to just log this, we see the reunion info is undefined. We can basically say equals and whatever value we want to give it, let's say na, and JavaScript tries to see if reunion dates in present in lz, it will use that, it will take that. If it is not, it will give it the value of na, or like whatever you specify here. So it's kind of like specifying a default value. And we can see, like, right now its reunion info is na, but if we just go quickly here and say reunion dates is, let's say, March, just, yeah, let's just keep it at March, uh, and the comma here, we can see the reunion info gets updated to March because it actually found it now. So you can use this equal syntax as kind of your fallback for the default value. And this is really great when you're looping through like a freshly loaded data set, trying to see if all of them have the correct values. If anything is missing, quickly replace it with the default value. And this is kind of good to know because in JavaScript we really don't have data processing libraries like in Python or something where you can do like a drop na or replace all or something. So it's good to have this syntax in mind. And like the final use case is what Alex mentioned earlier. We can use this spread syntax to kind of get multiple values, like return multiple values from a function. If you remember, like function usually allows us to only return one value. If you have multiple values, you can put them in an array. But then when you call the function, you will get an array, and then instead of using 0 and 1 to get your multiple values, you could just use this syntax. So we have return multiple as list, and we return an array of abc. If we use this square bracket syntax to declare it, we can just use the, you can just store the return value in 3 new variables. This is also great when you have a function which you are using from a library, right? So for example, like element, like event.selection is something that comes from d3, which is like a nested array. This syntax allows us to get individual variables without actually indexing into it. Same thing with object. If one of the functions returns an object with first, second, third, we can destructure the object into this key with using this syntax into the actual variables first, second, third. And the usage is same. The name of the variable should be the same as the return value, like one of the keys in the return value, otherwise it becomes undefined. You can also declare something and give it a default value, so all of that remains the same. But yeah, so this is quick like walkthrough to the destructuring syntax. You can get by without using any of this, but if you like learn how to use some of it properly, it really great. It really makes it easy. Sorry, it's okay. It really makes it easy to use it. Yeah, this is actually quite nice. So yeah, and I personally, like, I use the spread operators and all of the stuff, but I mostly use it for like initial processing of my data. I really like, this is like an horrible example of something to do. Like, never do this. This is too much. Yeah, because like if you give this to me quickly, like it takes me a second to like remember what this is. So yeah, we completed like the new JavaScript, like structuring, like spreading and destructuring syntax. Before we move on to like probably the most important part, like the promises. Any questions on this?
Yeah. At
Yes,
the very end, you,
this one.
yeah, you said that it has to have the same, like the variable when you restructure it.
Yes.
Has
So
the same name.
yes. So for example, first, second, third, like they should match the keys here. So for example, if we add, like let's say we misspelled third as, and we can see that it becomes undefined because it doesn't find the exact name there. Does that make sense?
Yeah.
Yeah. Yep. Any more questions? Okay, we will now move on to promises. So a lot of code, like so for I think for all the homeworks, all the code you have been writing, with the exception of probably the events, was basically synchronous code, right? You write a line of code, you write another line of code, and you know that the second line is going to be executed after the first one. So you know the order of execution. So promises basically are a way to write code in JavaScript where executions can be out of order. And this is required when we want to do something like loading a data, because JavaScript doesn't support a way to load data in a synchronous manner. So by synchronous manner, I mean, if we want to load a data and say where we kind of say load, we just, let's say we call a function called load data. There is no way in JavaScript to kind of know when the loading will be finished without using promises. JavaScript doesn't like stop everything to finish loading the data and then continue execution. But what JavaScript does is it gives us the mechanism of promises to kind of write code where we can specify that when you are done loading the data, do this. So we can't tell JavaScript to stop, but we can tell it what to do after the fact. So basically promise is basic, like as it sounds, right? It's a promise, or it's like an assurance of, you have told JavaScript to do something, it will do something, and now you can specify what happens when that thing is done. And there are kind of like different statuses a promise can be in. So when we ask JavaScript to load a data, it returns as a promise, and the promise now can be in different phases. So when we initially do it, the promise is in a pending state where we told JavaScript to do something, it hasn't done it yet, so it's still pending. After it's like, now that it's pending, it can go from pending to a settled state. So a settled state means it has done attempting like whatever you asked it to do. We still don't know whether the operation was successful or not, whether it loaded the data or not. We just know that it's done trying. And then once we have the settled, then in the settled phase we actually have two more states. One is called fulfilled and one is called rejected. So, and these are all like fixed keywords, right? These are not like some variable names we create. These are like promise statuses. These are defined in the JavaScript documentation. So a fulfilled promise has basically done what you have asked it to do. It has done loading the data. The data was loaded successfully. That means it had no errors accessing the file, whatever. A rejected promise can basically mean something went wrong during loading of the data. It doesn't specify one particular kind of error. It basically symbolizes any error we came across while loading. So this is like the most simple like model of a promise. A promise can be either pending or completed. And if it is completed, it can be successful completion or a successful failure. Yes. So yeah, and then to actually handle promises, like the very first, like the most simple syntax is to use a then operator. And you must have seen this syntax your in your homework code, where we give it as kind of the initial boilerplate. And the syntax essentially says whenever we call a function which returns a promise, or whenever we call a function which is asynchronous, we can tell JavaScript what to do once it has successfully completed it by using the dot then function. So we say this is like async with promise. So we say whenever you are done with whatever this function is, then do this activity. And dot catch basically says if you go to rejected state instead of fulfilled, do this activity. So we kind of can specify both things, because again, the point of promise is it will happen later, so we don't know, it might fail or it might be successful, so we kind of have to provide it both. It's optional to provide the catch, like you can skip catch, but if your promise fails, bad things happen, like your app will crash. So it's always recommended to like handle gracefully whatever goes wrong. And this is basically this catch is like essentially similar to if you are like exception handling try catch, if you're familiar with other prior paradigms. So yeah, so for example, here is like a concrete example, right? Promise dot then. So whatever this promise returns is passed to the result object, passed as a result to this then function, and then we can do whatever we want with it. And in our code here, let's say, great. Yeah. So in our code here, for example, CSV returns a promise, right? D3.csv returns a promise. And what we are saying is when the CSV file has loaded successfully, then do this. And the data actually is the values of the iris.csv file. So yeah. So basically the result is passed to the then part of the promise. If the promise throws an error, the details about what went wrong is passed to the catch or the second part. And this is another syntax to kind of specify your error handling. You can either explicitly say a dot catch, or you can pass in a second function to then, which is your error handling. And there are subtle differences between these two functions. So the difference is, if we use this syntax where we explicitly say a dot catch, this function will run if the error occurs within this async with promise part or in the then part. Anywhere error occurs, this function will handle the error. And in this syntax where you kind of just specify two functions, this function will only handle the errors coming from promise. It won't handle any errors which occur here. Let's say your console.log has some error. That error won't be handled by this because we didn't use a dot catch. So there is this subtle difference, and depending on your logic, you might want to use one or the other. I recommend using this one. Like this one always works, right? Because this one will still do async with promises, but it also does then. So you kind of get like a fallback for everything. Before promises came along, there was a way to handle all of this called as passing in callbacks. So you tell async one that, hey, when you are done processing, call this function, which calls async two, which you can pass in a function, and you can keep doing this and get this nice pyramid shape. This was called callback hell because you went into this loop of you tell one promise something to do, which returns another promise, then now you have to tell it something to do, and you keep going in this deeper and deeper, like passing of functions. It becomes really hard to write. So that's the reason they came up with this new promise approach of, like, instead of using callbacks, let's have a simple dot then function where you can specify if you're done with one thing, then do this. So here we have task one, we call async one, like the promise of async one is stored in task one. Then task two says when task one is done, like do something with async two, which itself will return a promise which we store in task two. And this kind of makes our code slightly readable. And then now that we have chained all of this, we can handle errors from all of this by just doing a dot catch on our last promise on the task three, and it will handle all the errors thrown like at any point in our loop. Uh, we can also do this with chaining, right? So the syntax for this is, for async one, we kind of give it the whatever we want. We do a dot then async two, a dot then async three. So instead of storing it at variable, we kind of just combine them with dot. This is like our D3 syntax of chaining, right? Dot attr, dot attr, we keep going on. So this makes it quite readable, quite easy to read. Let me make sure my mic is correct. Yeah. Okay. So this then syntax is great. It allows us to like chain things, create something like more readable than using async. But JavaScript now has like a more idiomatic way of doing things, which is an async await syntax. which basically allows us to write code without passing callbacks, without using then and catch. Essentially, using two extra words, you can write your code exactly as you write your synchronous code. So the way it works is, let's say we have a function where we are going to call a get users function, which is async, and normally we would handle it using then. So we would do get users dot then and do something. We can just say await for get users. So this kind of makes JavaScript so internally actually this gets converted to dot then syntax. It's exactly the same. It doesn't mean your JavaScript will actually wait. It's just a way to write your code so that you basically write it as the same as if it was waiting. Internally it will make sure that it will do everything in a dot then and handle everything properly. And the only requirement is, if you want to use an await keyword in a function, the await keyword inside a function, the function itself should be an async function, because when you use await, this function now returns a promise. So we kind of have to specify that, hey, this function is async and will return a promise. So you can now use await inside it. An exception to this is your initial script. Like if you open your first script file, you can use async directly. If you are not writing a function, you can use async directly in the top level. And this is like a fairly new addition to JavaScript world. It's called top level async. So like essentially we can just in our script tag, yeah, in our script tag here, we could directly like say await something, await d3.csv. Like this will work without writing async keyword, because like it's a new addition to JavaScript where you can await at the top level without actually specifying an async function. But again, like, so it's kind of up to you. Let's see. Yeah, it's kind of up to you which one of the syntax you use. Like this syntax is very readable. It's very idiomatic in the way that it's like regular JavaScript, or you can use the dot then syntax. I usually end up using the dot then syntax because in my mind it makes it clear that this is a promise and this will return a promise. With await, I kind of have to remind myself, oh, I see an await, that means there is a promise here. With dot then, I see a dot then, I know it's a promise. So, but yeah, like they both are completely interchangeable. You can use one or the other depending on what you want. So the main purpose of promises, or like more relevant to this class and your project, would be using promises for data loading. So whenever you read any file with D3, so this is a good example. We write a load data function. We say it's an async function. We put it inside a try catch, because when we use the then operator, we have dot then and dot catch. With await, we kind of have to do our own exception handling using try and catch. So we say we store the data in a variable called data. We say d3.json. We know d3.json is a promise. I mean, from documentation, we know it's a promise. So we can await it. So what will happen is, when JavaScript reaches this point, it will act as if it has to wait for the loading to finish, and only then it will say done plotting. If anything goes wrong while loading the data, it will throw an error. And we'll take a look at example, like how it works. So yeah, again the same. So we can wait for our data to load. We can do all our cleanup activity, and only at the end, like, our loading will finish. So now this is the example of like what happens if we don't use any await. We know that D3 CSV is a async operator. So if we run this code, the the usual order should be start loading data, done loading data, and our unscomp quoted. If we run, we get start loading data, done loading data, and instead of the actual data, we get a promise, and we can see this promise is pending, because when we logged the promise, it was pending. If we actually expand it, you can see that it's fulfilled, because like a millisecond after it logged, it was fulfilled, but it was too late for the log, and there is actually the entire data set as a result. So instead of dealing with this object, a better way to do it is just to async function read with await, and instead of just storing it in a variable directly, we do an await here. So we await for the result, and now if we console.log reading with await, we can see that it actually just logs the data without any of the promised things in it. So essentially this line of code only runs when CSV has finished loading and nothing went wrong in it. And we'll see an example of what happens when there is an error. So let's see. Yeah. Okay, so this is an example of doing the same thing with a callback. So what we can do is we can tell our function that, okay, when you are done, so we can create a function which takes a callback argument, and we can call this callback whenever we are done with our await, we are done with whatever await is doing. So essentially what we are doing is calling the read with callback, passing it a print as table function, and when it finishes loading the data, it actually prints the table. So this is fairly standard. Then the last part is then the next part is, another way to do this is using a then operator. So using a then operator is pretty straightforward. We do d3.csv, store it in the data. If we log the data, we see actually the first log is just a promise, but we can say data.then, and when in the then we can specify the actual data and we can log all of this, and we can see that inside the then the promise was logged as fulfilled, because then is only called when the promise is fulfilled. So logging the actual data promise inside a then will always return fulfilled. And if like, yeah, it can never return a rejected or a pending, if because if it was rejected it should go in a catch, and we don't have a catch. So yeah, this is how we handle errors. So what we are saying here is we are using the d3.json function to load our data, but our data is a CSV, so something should go wrong here. So, and we are saying dot then console log and dot catch error thrown, and we can see that it actually logs error thrown because we gave a CSV file to a JSON function. If we fix this to say CSV, we can see that it actually logs the then should print data, and it actually logs the data correctly. So yeah, that's how you usually log this. Let's yeah, if you want to write your own promise, we will skip these two parts. Like the important part of writing your promises, if you want your function to return a promise, you have to return the new promise object, which takes in a resolve and reject functions. And this resolve and reject essentially come from your dot then. So when we create a function status check with promise, return a new promise with resolve reject, and like write this boilerplate code of like if the status is successful, resolve, else reject. What this essentially does is it allows us to write this code where we say status check with promise then, and then this part of the code is actually passed here to resolve. Like this function is essentially the resolve function, and the catch function is essentially the reject function. So that way you can create your own promises. You shouldn't really need to create your own promises because the data loading already gives you promises, and it's already quite a pain to handle promises. So but you can. um, if you have multiple promises, let's say you're loading 3 different data sets and you kind of want your code to wait for all the data sets to finish loading, you can basically create, so d3.csv stores a promise in anscom, d3.csv stores a promise in iris. Now we can use something called promise.all and give it an array of all our promises, and this essentially and write a one single dot then for all of them. So what this does is it takes the results of both of these promises, puts them in a new array, and then passes it to our then function. So if we console log this, we can see that our result actually has two arrays. First is the anscom quartet, and second is the iris data. So this is a way to handle multiple promises. You can do it with multiple await statements. You can do a dot then for each of them. It's up to you. But if you want all of them like in a more idiomatic or simplistic way, promise.all lets you do that. Any questions with promises? The last part of this will be like debugging, like some helpful debug functions, but it's not really. And yeah, we have like 10 minutes to finish that. We should be able to do it in 10 minutes. Sorry, 2 minutes. Oh, it's still okay. So well, I'm assuming for your projects you're already using your IDs like Visual Studio or something, and not like a text editor, hopefully. So yeah, but Visual Studio, WebStorm is another option. Don't use Atom, like it's there in the documentation. I forgot to remove it. Like Atom was maintained by GitHub. Microsoft bought GitHub, and Microsoft does Visual Studio. So I don't know how long Atom will stay around. Sorry. Yeah, it's yeah. So yeah, don't use Atom. Um, so just quickly, like apart from console.log, There are other helpful console functions like info, warn, and error, which kind of allow you to like do some fancy debugging. Like, so yeah. So when you do console.error, you get this like red colored console log. You can use it while debugging to like highlight some important points. You can also use console.trace. And what console.trace does is it kind of gives you a list of functions which triggered this console log. So it tells you that console.trace was called in call third, which was actually called in call second, which was actually called in call first, and it gives you a nice log of. So this is great for debugging when we want to know what actually triggered the error. Uh, there is console.time and time end, which allows you to kind of specify start and end and get a time difference. So this is really useful. But yeah, then there is console.group, which allows you to group your console logs into levels where you can like collapse them. This is great if you are like consoling logging a big list and you kind of want to make it more readable by just collapsing it. So console.group, basically you have to specify the name of the group and the group end with the same name, and it will basically start and stop grouping it. And visually it looks something like this. When you say group in level 1, everything is inside level 1 and you can collapse it. But yeah, like that's pretty much it. Console.table, I'm sure I must have showed some of you in the class in the office hours, but console.table logs your list as a table instead of like where you want, instead of an object where you want to expand individual. Great for debugging your data, just logging your data and looking at it. um but yeah, I mean that's pretty much it. Like that's pretty much everything related to debugging. Cool.